Hello, you wonderful people of Earth. How are you? Welcome to another rockin' video. All right, today we are going to talk about integers even more, but we're going to talk about word problems. Stop with all the excitement. I know you're celebrating. I can hear you from all the way up wherever you are. All right, what is bought by the yarn and worn by the foot? Bought by the yard, worn by the foot. Oh, I get it. It's a carpet. You buy it by the yard and it wears out because of your foot. Oh, that's a math joke. I'm not going to say it's a good one, but that's a math joke. All right, let's get going. All right, so today you're going to work on estimating, determining, and justifying the solution to one and two-step contextual problems. What does that mean? You're going to solve word problems. You're going to try to think your way through them. You might have to estimate a little bit, but you're going to determine out what's the best idea, how do I solve it? And we're going to be focused on adding, subtracting, multiplying, and dividing integers. All right, so here's some tips, if you will, from the big guy. Drawing is your friend. Anytime you work with me, if you come up and work at my desk or you ask a question about a word problem, one of the first things I do is grab a whiteboard or paper and I start asking you questions about drawing out the scenario. I always like to tell kids, sometimes they look at word problems and they just hop in and say, oh, here's some numbers. What should I do with them? Ask yourself, what is the question's final goal? It's amazing how many times kids sit down and do so much amazing math work but they don't answer the question that it's actually asking. So be careful. What do they want to know? So you know what you're trying to solve. And then always double check your computations. You're doing some addition, subtraction. You did all this wonderful work. You thought your way through it. You drew all the pictures. You did all the things. Go back and double check your work to see if it makes sense. Okay. And then read the answer back into the question because sometimes that'll help you understand if your answer made sense. So, for example, if the question said something like, how many dogs would be in an event if blah blah blah, and the question's saying how many dogs, and at the end of it you said 1,713,000, and you're like 1,700,000. Why would there be is there that many dogs? Like what in the world? See if you answer the right question. If it doesn't seem like it sets off a flag, you're like, oh, that doesn't make any sense. Go back and see if you answered the right question, check your math, and go from there. All right. So let's dig in. Notice at the top, I put all the clues. I said, what is drawing is your friend? What is my final goal? Let's double check and let's read the answer. So let's make sure we're thinking about those as we're asking these questions. So at sunrise, the absolute temperature is 1 degrees below zero. By noon, the temperature rose by 17 degrees and then fell again by 13 degrees by nighttime. What was the temperature at the end of the day? So, well, let's think about that. We're talking about temperature. So when I think of temperature, I think of a thermometer going up and down. So I'm going to go ahead and draw myself a little up and down thermometer. And guess what it's going to be? It's going to sort of be a number line, isn't it? So the outside temperature was 1 below zero. So I'm going to go ahead and put 0 here. Okay, so this is where I'm starting. And then it said the outside temperature was 1 below zero. So we're at -1. Okay. By noon, the temperature rose by 17. So from 1, it went up by 17. So, in other words, I'm saying what is -1 raised? It went up. So the temperature rose. So we're adding it to it, right? We're adding 17 to it. So if I go up 17, -1 plus 17 is going to get me all the way up to 16 degrees because this was 1. And I went 2, 3, 4, 5, all the way up to 16. I did 17 more of them. So now we're at 16. And then it fell again by 13 degrees by nighttime. So where are we at? We're at 16. And we're going to fall by 13. And on a thermometer, if you fall or go down, you are subtracting. So we went from 13 down, -13, and we're going to end up at 3. Let's just make sure that's worked. What's 16 minus 13? 3. Okay? So let's check our computations. What was our final? Well, first of all, what's our final goal? They want to know what is the temperature at the end of the day. I feel pretty good about that. We started at 1. We dropped 17 and we added 13 because it went back up and we ended up with 3 degrees. All right, double check my computations. Okay, so I was at -1 and I added 17. So I know when I'm adding integers and their opposite signs, I subtract. 17 minus 1 is 16 and I keep the sign of the bigger number, so it would have been 16. Feel good about that one. And then we take that answer and we drop it by 13. 16 minus 13, 14, 15, 16. Now 3 away. I feel pretty good about that. And then read the answer back into it. What was the temperature at the end of the day? The temperature at the end of the day was 3 degrees. I feel real good about that. I drew my picture. Notice it's not like a Mozart. I'm not Mozart. It's not a Picasso. It's not one of those most amazing pieces of art you've ever seen. It's literally just something to kind of guard my ideas and to guide my thinking to kind of help me. Because some of them will be a lot harder than that. And you'll want to be like, I just can't figure out where I need to go from here. Because as you get farther into math, you might have problems that are 6, 7, 8 steps long. Okay. Let's try this next one. Okay. The local movie theater reported losses of $475 each day for 3 days. What was the loss for the 3 days? Okay, first of all, let's think about some buzzwords in here. I see a word losses. So if we have money and we lose money, are we going to be going up or down? Well, losses means we're going to go down. And when we make a number smaller, we're either going to be dividing or subtracting. So let's just focus on that right now. Keep that in mind. And then each. Oh, each. Anytime you see each or per, that means they're going to be repeating something over and over. And a lot of time when I see the word each or per, I immediately head towards multiplication. Okay, so I have subtraction here. I mean, it's going down by $475 each day. We're doing that for 3 days. So what was the loss for the 3 days? Well, let's draw a picture. So we got one day. Okay, they lost $475. Okay, so they lost $475, right? Okay. On the day two, how much did they lose? You're right, they lost another $475. So they lost another $475. And then on the final day, they lost another $475. So we want to find out what was the loss for the 3 days. There's a bunch of ways you could solve this. Okay, so simply if they lost this and then lost this and then lost this, you could just take all that and add it up and it'll tell you how much they lost in all. Okay. Or we can say it's three of the same number. So anytime you're adding the same things over and over, you can multiply. And that's where this number comes in, or this guy came into play. So you could take 475 times 3. Okay. If I do that, if I take 475 times 3, I got 3 groups of 5, which is 15. I got 3 groups of 7, which is 21, plus that guy left over, which is 22. And then I got 3 groups of 4, which is 12, plus those 2 guys. So how much money did they lose for all 3 days? They lost $1,425 3 days. Okay. That makes sense? Yeah, it does. Because if they lost, so one of the things that people might make a mistake here is you see that losses and it tells you a negative. So they didn't lose negative $475. They simply lost this value, 1,425. Okay. All right. Let's go to the next question. I'm going to switch over to a pen to make my writing a little bit smaller. A person has a debt of $200. And ask yourself if you know what debt means. That means they're in the hole or they owe $200. So these 5 friends, well, we got a number, 5 friends offer to pay all of the debt. How much does each person need to pay in order to pay off the debt? So each and per always make me think of multiply and divide. Okay. So let's talk about this. So here's a person who is, let's just draw this rectangle here and say they are $200 in the hole. So they have lost $200. So there's my picture. I'm just making sure I understand that. Now we have 5 friends who offer to pay all the debt. So 5 friends are going to pay it for this person. So each one of them is going to pay the same amount of money. So they're going to pay a part of the 200, an equal part. So if we're taking a bigger number and we're breaking it into 5 equal parts, how much money is each person spending? Okay. Well, if we take a number and break it into 5 equal parts, that's where you got to start thinking about which of the operations am I going to use? If you've noticed in the videos that we worked on with operations, I always gave you a hint on what other words to think about. I said in division, I said we're going to take this number and break it into smaller groups. So we're taking 200 and breaking it into. So we are taking 200 and we are breaking it into 5 groups. Okay, so how do you do that? What's 200 divided by 5? Well, how many times does 5 go into 2? It does not. How many times does 5 go into 20? 5, 10, 15, 20. It goes into it 4 times. 4 times 5 is 20. Subtract, we get 0. Bring down the last 0. How many times does 5 go into 0? It does not. What's 0 times 5? It's 0. We subtract. We got nothing left over. So our answer is telling us that each kid is going to pay $40. Let's check that again. So let's check and make sure our answer makes sense. So the opposite of division is multiplication. So let's take 40 and multiply it by 5. 5 times 0 is 0. 5 times 4 is 20. Bingo, they worked. Does the answer make sense? Are we answering what they want to know? 5 friends each pay $40 to pay off the $200. Good work, y'all. Good work. Do another one. I think we got one more. Yep. Carrie and Joy spent $8 for gasoline, $15 for their lunch, and $5 apiece for gifts for grandma. If the girls left home with a total of $50, how much do they have for the return trip? Ooh, something in here that might be kind of tricky. Okay, so first of all, let's add up their items. Okay, so we got gas. How much did they spend in gas? Well, they spent $8. Okay, how much did they spend for lunch? Well, lunch they spent $15. Okay, and $5 a piece for gifts for grandma. This is where most people would make a mistake. They would write down here, say, oh, $5 for grandma. But they didn't spend $5 for grandma. They spent $5 a piece, which means each of those spent $5. And if both of them spent $5, then they spent a total of $10. 5 times 2, or 5 plus 5 is 10. Now, remember, this question is, so this is kind of our drawing right here. See, it's not really like, sometimes it's not a drawing. I'm just collecting my data. And then ask ourselves, what is our final goal? How much do they return with? Okay. You can think inside your head what kind of mistakes people would make. Some of them would just might add this up and say that's how much she spent. That's not what they're asking. They want to know how much she returned with. So this is a two-type question. They came with $50. All right. They went on this trip and they had $50. So that's important to know. Okay. But what we got to figure out now is how much did they spend before we figure out how much they had left. So let's add this up. What is 10 or 8 plus 5? It would be 13. One up here. 1 plus 1 plus 1 is 3. So Carrie and Joy spent $33. Is that our final answer? No. Our final answer is how much did they return with? Well, if they left with 50, they spent 33, what do you think we need to do? Add $50. And of that 50, 33 of it went out the door. They no longer have that 33. We're kind of asking ourselves, what do we have left? Well, let's get rid of the 33. And we're going to subtract it from our wallet. Got rid of it. Went away. They took it away. So can't take 3 away from 0, so we borrow from next door. 10 minus 3 is 7. Then 4 minus 3 is 1. So, does my answer make sense? Well, how much do they have for the return trip? They still have $17 left over after spending $33. So this is our final answer. For all your pictures, make sure your data is correct. Make sure you're answering the right question, and always go ahead and double check that work. All right, double check that work. What is full of holes and can still hold water? Kind of a science question. It's just a sponge. It's full of holes and it holds water. Let's go. Oh, video's over. See ya.